Back, everyone. So today we have a lot of stuff to cover because of our compressed schedule, but the basic theme is the motion of the night sky. So what I want to do today is introduce you to how the stars move throughout one 24-hour period, and then also throughout one annual period. So we have two distinct motions, not to be confused. And we want to learn how those motions of the Earth along its rotational axis and also during its revolution about the sun affect the night sky that we observe. And this is important for you all because if you point your little radio telescope in a particular direction, you're going to be slicing through a different part of the sky. And we want to be able to relate that direction to the part of the sky that's of interest later. Last time, we kind of went through where we are in the universe and the associated motions. Today we're going to be dealing with the motion of the Earth rotating about its axis and also the revolution of the Earth about the sun, so those two motions. In the second week, we will be dealing with the motion of the entire solar system about the center of the Milky Way. And so this motion turns out to be really important for your observations, but we won't cover it until the next week. So what we'd like to do today is first introduce some definitions, what the universe looks like from the Earth, the constellations, a trick that we use called the celestial sphere, which is a model for the night sky, not a physical thing, but a model. And then we want to talk about, most importantly, how the night sky moves in its daily motion. And then later I'll have another one of these slides for the yearly component, but I want to keep those separate because they really are quite distinct. Along the way, we have a number of different words, new definitions, and I'll highlight those just so we can talk about them intelligently. So we've got about 2,000 stars that you can see with your naked eye. If you remember from last lecture, there's on the order of 100 billion stars in the galaxy. So the actual view that you have, even in a very clear sky from somewhere dark in West Virginia, is just a small sampling of the overall galaxy. Other things you can see are comets, occasionally satellites. If you kind of look in a blank patch of sky, sometimes you'll see a little faint white trace. That's a satellite usually. They will move in all directions with respect to the stars in the cardinal direction, depending on their individual orbits. We can see a handful of galaxies, a handful of star formation regions, but basically our view of the night sky is a poor comparison to the actual sky, which is much richer than what we can see with our naked eyes. Astronomers use constellations in a slightly different way from how they're used colloquially, and that is that we treat them as map boundaries, and this is not really important for what you're doing. Aside from the fact that if you say you are pointing your telescope toward the constellation of Andromeda, that has a real physical meaning because Andromeda has boundaries that are agreed upon by all astronomers. So you don't have to become experts at identifying constellations in the night sky, but it is often handy if you are trying to collaborate with someone, if you can say, oh, I'm looking towards Perseus. Okay, I will look toward Perseus as well. Now, at the resolution of your telescopes, you'll have basically everything within one constellation observable with your little tiny telescope, because they actually observe a large swath of sky at any given time. So identifying things by the constellations is actually not a bad way to do things. I bring this up mostly as a point of interest, not because it's important for your particular observations, but the constellations are, of course, not physically grouped together on the sky. In astronomy, we always struggle with that third dimension of distance. So we know on the sky one direction and the other direction, but it's that third dimension that we don't know. And this slide is meant to point out that if you look at, say, the Big Dipper, each star in the Big Dipper has a different distance from the Earth. So if you were able to go above the galaxy and look down on the Big Dipper, they would not be associated at all. They're all at different distances in a different part of the galaxy. So it's just a convenience. They're not actual groupings.